At this point, I want to go over what are the exact properties that vectors in the plane have. And so we're going to be very specific here. And we're going to talk about 10 properties that the vectors have. In what follows, u, v, and w are vectors in the plane. So vectors like we were just talking about, c and d are scalars. Scalars, for now, means real numbers. So you can just really just think it's anything that when I say it's a scalar, just say it's a real number. Scalar is really a more general term than that. But for now, scalars just mean real numbers. At the end of the semester, if we have time, we'll talk about situations where we can take scalars outside the real numbers, say the complex numbers, or even in more exotic fields. But we'll deal with that later. So the first property that vectors have is that if you add two vectors together, you get another vector, and that's third vectors in the plane. So if you add two vectors in the plane, you get another vector in the plane. The second property is that if you add two vectors, the order doesn't matter. So u plus v and v plus u are the same. Okay, so if you travel along u and then v and then or v and then u, you'll get the same thing. So we say that addition is commutative. Commutative is a fancy word for saying the order doesn't matter. Okay, so addition is commutative. If you were to add three or more vectors, it doesn't matter how you group them. If you want to group the last two vectors first or the first two vectors first, it doesn't matter. Okay, so we say here addition is associative. So it doesn't matter which two vectors we associate to each other first. Item 4 here is that there exists as a vector, zero vector. In this case, it's the vector 0, 0. So that if you add it to any vector u, you get itself. You could think of the zero vector as the vector that says stay put, don't move anywhere, right? If we're thinking of vectors as a set of instructions, the zero vector says don't move. Okay, so here I guess we can call this existence of the zero vector. Okay, next, for any vector u, there's another vector minus u, namely the same vector in the opposite direction, so that if you add them together, you get the zero vector. So here this is the existence of an additive inverse. Okay, so that's or the additive inverse property, however you want to say it. C times u is a vector in the plane, so if u is a vector and c is a scalar, then if you scale that vector, it's still in the plane. Not surprising, but it's a good property to write down. 7 and 8 are distributive properties. So if you distribute a constant across a sum of two vectors, or if you distribute a sum of constants across a vector, you get what you expect, basically. Okay, so those are both distributive properties. That I better write down. So these are distributive properties. Item number 9 says that the scalar multiplication is associative. So if you want to multiply c times d first, and then multiply that by the vector u, that's the same as multiplying d by u, and then whatever that vector is, you can multiply by c. Or since real multiplication of real numbers is commutative, you can also write this as dc times u. So that's kind of an extra property there. But you could think of this as kind of an associative property of scalar multiplication. And then the last property is that if you take any vector and you scale it by 1, meaning that you multiply it by the real number 1, you're not changing the vector. You're multiplying it by 1, you're scaling it. It's not actually changing any length. It's not changing direction. You just get back the original vector u. Okay, so these are the 10 properties that vectors enjoy.